Hello, and thank you for coming to my exhibit presentation. Today I'm going to be going over some work I'm doing in my PhD entitled, Are Some Frailty Tools Not Appropriate for Physical Activity Research? Background. The older adult population is growing and will continue to grow. For example, here in Canada, according to the Canadian Institute for Health Information, over the next 20 years, the older adult population is expected to grow by 68%. However, when people talk about the aging population and healthcare, they're often referring to the older adult population growing older and becoming frail. Age and frailty is not synonymous, however, they are related. Therefore, it's important to understand how this population is aging, along with the fact that they're simply increasing in chronological age. Frailty is defined as a multifaceted condition that reduces one's physiological reserve, which ultimately leads to a state of increased vulnerability. As frailty increases, quality of life decreases, and there's an increase in healthcare resources. Therefore, it's important to ensure we find ways to prevent and reduce levels of frailty. To date, physical activity interventions are the most promising method for mitigating frailty. Recent systematic reviews and meta-analysis support this. For example, in 2019, a systematic review and meta-analysis of randomized controlled trials stated that physical activity is the most effective frailty intervention. However, how frailty is measured in these studies may be something we need to consider. Many frailty tools exist in the literature to identify frailty, such as the frailty phenotype, the FOF index, and the frail scale, to name a few. Although many of these are commonly used to validate for screening purposes, there could be issues with them being used in physical activity research. For example, the frailty phenotype uses shrinking, weakness, exhaustion, slowness, and low activity to identify frailty. However, low activity uses a physical activity questionnaire itself within the tool. For the frailty index, there could be too many variables that physical activity cannot change, such as have you fallen in the last year and do you have poor vision? An example comes from 2019. A study included 112 men and women who were over 70. These individuals were randomized into two groups, either a control group or an intervention group, and 3 frailty tools were used to capture frailty changes. Over 6 months, the control group engaged in routine activities, and the intervention group was involved in individualized progressive multi-component exercise program at a moderate intensity. At post-intervention, frailty changes were observed in the intervention group compared to the control group by the frailty phenotype and the Tilburg Frailty Indicator after 6 months, but not the FOF index. This is just an example of how, depending on what frailty tool you use, you may capture different findings. Which brings me to the objective of my study. This study aims to understand if associations between frailty, physical activity, and sedentary time vary based on which tool is used to measure frailty. Methodology. This cross-sectional study used the NHANES database. NHANES is a program of studies designed to assess the health and nutrition status of adults and children in the United States. The 2003 to 2006 cycles were used, and individuals were included in the analysis if they're 60 and older, had valid frailty tool data, and had valid physical activity data. Here are 3 of the 4 included frailty tools for this analysis. They are modified versions of the frailty phenotype, the FOF index, and the frail scale. The frailty phenotype was previously published using this method. The FOF index and the frail scale were developed using similar variables within the NHANES database compared to the original tools. The frailty index has also been previously published using this method. The NHANES FI includes 46 items seen here, including deficits that reflect disability, comorbidity, symptoms, and laboratory values. Moderate to vigorous aerobic activity and sedentary activity were collected with hip warm accelerometer pictured here. Individuals are asked to wear this device for all waking hours over 7 days and to remove them during water-based activities. Individuals were not included in the analysis if their data was unreliable or had too little valid days. Resistance training was self-reported, asking if individuals to report the amount of resistance training they engaged in over a month. This value was divided by 4 to account for resistance training per week. Statistical analysis. I used linear regression to examine the association between frailty tools and physical activity variables. Three-way interactions were tested for frailty tool, age, and sex, and models were adjusted by age, sex, race, marital status, education level, and accelerometer wear time. Results. The final sample was 1,965 people. The average age was 70 and 48% were female. Also, over half of the population was Caucasian. Here are the frailty descriptives of the population. The average FI was 0.18 and 2.7, 9.4, and 3.2% of the population was considered frail by the frailty phenotype, the FOF index, and the frail scale, respectively. Next are some descriptives of activity by frailty tool. Here you'll see the average amount of moderate vigorous aerobic activity a week by frailty tool and frailty category. This graph clearly demonstrates that time spent in moderate to vigorous aerobic activity decreases as frailty increases. When looking at resistance training sessions per week by frailty tool and category, here we'll see that most people report engaging in approximately 1 resistance training session per week across frailty levels. These graphs demonstrate that everyone is very sedentary for the most part, but there seems to be a trend that as frailty increases, so does sedentary time. There's too much information to show all regression coefficients, so I'm providing summary tables of the analysis. The green arrows show a significant negative association, while the X shows no association. Here you'll see that there's varying results, with some analysis demonstrating that time spent in MVPA, or moderate to vigorous aerobic activity, decreases as frailty levels increase. However, interactions depend on what frailty tool is used. For example, we notice that results differ by age. Even so, across ages, we show that frailty index is higher for lower levels of MVPA. As FI increases, MVPA decreases. For the frailty phenotype, we found that results differ for people who are classified as pre-frail or frail for males and females. For pre-frail females, there's no association by the frailty phenotype with moderate to vigorous activity. For frail females, the higher the frailty, the lower the MVPA, or moderate to vigorous activity. For resistance training, to note, there's no association between increased frailty by the frailty index and time spent in resistance training per week. Another point is that males who are pre-frail or frail by the FOF index show that compared to being robust, the frailer you are, the less resistance training you engage in. The other tools show conflicting narratives, however, only the FOF index has sex and age differences to take into consideration. For sedentary time analysis, most tools show as frailty levels increase, so does the time spent in sedentary activity, excluding males who are frail by the frailty phenotype. Conclusion. For the MVPA analysis, for all frailty tools, it is important to consider how much time is spent in MVPA, or moderate to vigorous activity, by sex and age. All analyses show that on some levels, frailty increases and MVPA decreases. Resistance training shows that compared to those who are robust, being pre-frail or frail is associated with engaging in less resistance training per week. Only the FOF index needs to consider age and sex differences. All tools show that being more frail is associated with increased time and sedentary behaviors, except for frail males by the frailty phenotype. Only the frailty phenotype needed to be stratified by sex. There are some limitations to this study. It is a cross-sectional analysis, and it includes modified versions of the frailty phenotype, the FOF index, and the frail scale. Also, resistance training was self-reported. In my opinion, as a total project, understanding if specific frailty tools may be appropriate for physical activity research is a question I can't definitively answer, as I'm only able to draw from cross-sectional associations. However, what the results do show is that depending on what tool you use, you could have different associations by physical activity. And also it shows that including age and sex differences is important. Personally, I believe that the frailty phenotype is highly problematic as physical activity research due to physical activity being measured within the tool. If I had to pick a tool, I'd use the frailty index due to its adaptability to include non-problematic items into the tool to track the real impact of how physical activity can be associated or impact frailty. Thank you.